ക്ലാസ് കംപ്ലീറ്റ് ചെയ്യാൻ. ഓക്കെ, ഇതൊന്ന് ചെയ്യാവട്ടെ. സിസ്റ്റം സ്ലോ ആണ്, പ്രോബ്ലം. Today we want to discuss Straussen's matrix multiplication. System slow on, that's the problem. Wait. Okay. So, please give your attendance in the chat box. Adarsh, please give it now. Okay. So, in the previous class, we discussed about merge sort algorithm. Merge sort algorithm. Then, today we want to discuss Straussen's matrix multiplication concept. Straussen's matrix multiplication concept. Here, first we want to discuss the normal matrix multiplication. Okay, how can perform matrix multiplication of two square matrices of same order? That we want to discuss at first. Then we want to discuss how the matrix multiplication can be performed using divide and conquer approach. Okay, so matrix multiplication can be performed using the divide and conquer approach also. That we want to study next. First, we want to study the normal matrix multiplication. Second, we want to study how we can apply divide and conquer approach for matrix multiplication. Then in the last part, we will discuss the Straussen's matrix multiplication. Okay, so basically Straussen's matrix multiplication uses the divide and conquer approach. Okay, so now you can note here how we can perform the matrix multiplication. For example, here there are two matrices. Okay, one is A and another is B. Okay, there are two matrices given. One is a square matrix of order, 2 by 2. This is a matrix. Okay. Similarly, another square matrix is given, B. Its order also 2 by 2. Okay. So now we can perform matrix multiplication, and we will get a matrix C. Its order also 2 by 2. It's also order 2 by 2. And this matrix multiplication basically performed using this equation. The elements in the matrix C is obtained by the elements in the matrix C is obtained by using this equation. Okay. Which are the elements? C11, C12, C21, C22. These are the elements in the matrix C, and the elements are obtained by using this equation. Okay, this equation. That is, in general, we can say Cij is equal to sigma k equal to 1 to n aik into bkj. Okay, aik into b bkj. Okay, aik into bkj. So this is the general equation for getting the elements in the matrix C. Okay, so this is the general equation. How can get a C11? How can get a C11? C11. C11 is equal to, how can get C11? This element can apply this equation. We apply this equation, we will get C11. C11 we will get. So C11 is equal to A11 into B11 plus A12 into B21. Okay. Anyway, this is the using this equation calculate all the elements. Okay. So you should study or you
സർ കേൾക്കുന്നില്ല.
Okay, lab connection issues under. Okay, anyway, I will take this class using the mobile. No problem. So, okay, so this is our Strauss matrix multiplication concept. Here we want to study the Straussen's matrix multiplication. Okay, Straussen's matrix multiplication we want to do. Okay, so first we will discuss the normal multiplication concept. Okay, so our traditional matrix multiplication concept we will study at first. Okay, so in the normal matrix multiplication, there are two matrices given. Here we are considering the both matrices are square matrices. Okay, so here you can note here. This is a there is a matrix A. Its order is 2 by 2. There is a matrix B. Its order is 2 by 2. Then we want to get a matrix C. Its order should be 2 by 2. Okay. Then how we can get it? We can use this equation. Cij is equal to sigma k is equal to 1 to n aik into bkj. Okay. By using this equation, we can get all the elements in the matrix C. Okay. We can get all the elements in the matrix C. Okay. We can calculate C11, C12, C21, C22 using this equation. Okay. Cij is equal to sigma k is equal to 1 to n aik into bkj. Okay. So, is it okay now, Anaka?
Sir, okay.
Okay. Okay. So next, we are using the if we used the traditional approach of matrix multiplication, then we can write the program in this way. Okay. So you know already you studied matrix multiplication code. There are three for loops. Okay. For I equal to 0 to n I plus plus, for j equal to 0 to n I j plus plus, then we will initialize the C matrix to 0. Then there is the innermost for loop will perform the actual multiplication. Okay, we can write in this way: C of ij is equal to C of ij plus A of ik into B of B of k of j. Okay, you can note this code. Okay. So, if we performed the matrix multiplication in this way, the time complexity will be big of n cubed. Okay. This is the time complexity for performing the matrix multiplication. Okay. So, now we are discussing how can I use divide and conquer approach to solve this problem. Okay. How can use divide and conquer approach to perform matrix multiplication. So, what you can note here, there is a matrix A. Okay, A is equal to A11, A12, A21, A22. B is B11, B12, B21, B22. Now you want to obtain a matrix C. The elements are C11, C12, C21, C22. Okay. So we can calculate in this way. What is C11? C11 is equal to A11 into B11 plus A12 into B21. C12 is equal to, you can get four equations here. You can note here, there are four equations. Okay, there are four equations. Okay. There are four equations. C11 is equal to A11 into A11 into B11 plus A12 into A12 into B21. C12 is equal to C11 is equal to C12. Similarly, you can calculate C22, then C21. Okay. By using our traditional approach, of matrix multiplication. Okay. So now I given this equation as equation number 1. Okay, equation number 1. Okay. So there are two square matrix of order 2 by 2. Okay, 2 by 2. Then I can perform matrix multiplication and I can get the elements C11, C12, C22, C21 in this way. C22 in this way. C21, C22 in this way. Okay. Next, so in this case, the number of multiplications needed is number of multiplications needed is equal to 8 and number of addition needed is equal to 4. Okay, you can note here. Here we are performing 8 multiplication and 4 addition to get 4 elements C11, C12, C22, C21. Okay. Okay, please wait. Okay. 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 So okay, Sarang, is it okay now? Sarang? Sarang?
Hello, sir. Hello.
Oh, okay. Wait. Okay. So here you will get you can calculate C. You can get C11, C12, C22, C21 in this way. Okay. C22 in this way. So this is equation number 1. Okay. I put equation number 1. Then, so you can note here. So the number of multiplications needed here is 8 and number of addition is 4. Okay. Number of addition is 4. can note it here. Number of multiplication needed is 8 and number of additions is 4. So to get these elements C11, C12, C22. So for getting the elements C11, C12, C21, C22, we need to perform this, and then for that you need this number of multiplication and then this number of addition. What is divide and conquer approach means? Here, suppose the matrix order is 4 by 4. Okay. Suppose the matrix order is 4 by 4. Okay. It is 4 by 4. Then what we will do? This is 4 by 4 matrix. Okay. This is a 4 by 4 matrix. And this is also a 4 by 4 matrix. Okay. There are two 4 by 4 matrices there. Then what we will do is that we will divide this matrix 4 by 4. In this way we can divide. Okay. That is, there are 4 2 by 2 matrices. Okay. There are 4 2 by 2 matrices. Okay. This is a 2 by 2 matrix. In this way, there are 4 2 by 2 matrices. Okay. Similarly, so then we can note here. We can consider this as A11. This is A11. This is A12. This is capital A. Okay. Capital A12. This is capital A21. This is capital A22. We can divide B in this way. So we can partition into 4 matrix of order 2 by 2. So this is B11, this is B12, this is B21, this is B22. Okay. B22. So next, how can calculate C11? Note here. C11 is basically equal to C11 is equal to A11 into B11 plus A12 into B21. We will get there is a matrix C. We can write this. This is C. C11 is obtained by using our traditional matrix multiplication approach. That is, how can get a C11? A11 into B11 plus A12 into B2. Okay, this is our traditional matrix multiplication approach. So, C11 is obtained by multiplying A11 with B11 plus A12 into B21. Okay, so we can write in this way. C11 is obtained in this way. C12 is obtained in this way. C21 is obtained in this way. C22 is obtained in this way. Then we will get these elements. These elements. So this will be the multiplied matrix C. This is C. Okay. So which means we can do the matrix multiplication in this way also. That is, if this is a 4 by 4 matrix, we can partition into 4 square matrix of order 2 by 2. Then take this element as A11, this is A12, A21, A22, B11, B12, B21, B22. Then apply the matrix multiplication concept. Okay. Then we need to only calculate only these values: C11, C12, C21, C22. That can be using this. You can obtain these values. So this is the divide and conquer approach. This is the divide and conquer approach. Okay. This approach is called the divide and conquer approach in matrix multiplication. So this will be the algorithm for performing matrix multiplication in this way. So what we will do is that there are two matrices A and B. There are two matrices A and B, and its order is n. First, we will check n less than or equal to 2. If n less than or equal to 2 means it is a small matrix of order 2 by 2. Okay, it's a matrix of order 2 by 2. Okay, in that case, what we will do? We will just perform this matrix, this concept. Okay, this is the situation now. That is a small problem of size 2 by 2. Okay, 2 by 2. So what we want to do? We can apply this. Then or equal to 2, we will perform multiplication in this way. Okay. We will perform matrix multiplication in this way. We can matrix multiplication using this approach and solve it. If n greater than or equal to 2, what we will do? We will partition. For example, n is equal to 4. Then what we had done? We partition the matrix in this way. Partition the matrix in this way. Okay. We partitioned the matrix in this way and repeatedly performed matrix multiplication. That is, first we partition the matrix into A11, B11, then its order will be n by 2. Then plus A12, B21, n by 2. This in this way. A11, B11, A11 into B11 plus A12 into B21. So A11, B11, then A12, B21, A12, B21. This is plus. Then again we will call the function in this way. So we will make 4 recursive call mm. Next is A11, B12, n by 2 plus mm of A12, B22 by 2 and so on. So this concept is implemented in this way. This is the algorithm for implementing this concept. Then what we will do? Then we will analyze the complexity. Okay. In this case, the complexity of performing the multiplication will be 8 into n by 2. Okay. So this is the program for this. In this, there are 8 calls. This is 1, 2, 3, 4, 5, 6, 7, 8. There are 8 multiplication calls are there. So 8 into t of n by 2 plus n square. What is n square? Each time we are performing an addition. Plus is there. Okay. This is plus. This is plus. This is plus. That is 4 times we are doing the addition. So it will be n square. Why? Because matrix addition takes matrix addition. Plus is a matrix addition. It will take n square time. So it will be c into n square. So after C into n square. After solving using Master's theorem, you can obtain order. This is n cube. This is also n cube. Okay. This is also n cube. Traditional approach also n cube. Divide and conquer approach also taking n cube. Now what we want to do is that we want to apply the Straussen's matrix multiplication. Here 7 formulas are used. Okay. Here 7 formulas are used. These are the formulas used. P is equal to A11 plus A22 into B11 plus B22. Okay. So what is A11? What is A11? A11 is this by 2 matrix. Okay. A11 is this 2 by 2 matrix. After solving this 2 by 2 matrix, you will get a value that is A11. Okay. Similarly, we can find other values. So here we are forming 7 equations using that A11 plus A22. In this way, there are 7 equations. PQ, RS, T, UV, UV. Then we will calculate C11 in this way, in these equations. C12, C21 in this way. So by doing this way, we will get the final C matrix. So the complexity of this algorithm will be 7 into T of n by 2 plus n square. By solving it, you will get big of n raised to, using Master's theorem, you will get big of n raised to 2.81. Somewhat its complexity is reduced. So this is the Straussen's matrix multiplication concept. We can discuss that in the next class. Okay. Please give your attendance in the chat box. Okay, thank you.